The rebuild of a crashed Bugatti Chiron has emerged as one of the most widely discussed automotive stories circulating across the internet. At the heart of this attention is Mat Armstrong, a YouTuber widely known for restoring heavily damaged supercars that many people assume are impossible to bring back to life. What initially began as a straightforward restoration effort has gradually developed into something far more significant, capturing the interest of car enthusiasts, while also prompting deeper questions about what manufacturers truly allow and what they may choose not to disclose. This specific project centers around a legendary Bugatti Chiron, a hypercar renowned for its extraordinary performance, cutting-edge engineering, and extremely high value. After being involved in a crash, the vehicle was officially declared beyond repair by the manufacturer, effectively classifying it as a total loss. Under normal circumstances, such a decision would mark the end of the vehicle's life cycle, preventing it from ever returning to the road. Despite this, Mat Armstrong made the decision to take on the challenge, with the intention of demonstrating that even the most complex machines can be rebuilt when supported by sufficient expertise, patience, and creativity. From the very beginning, many observers doubted whether the project could succeed, especially since Bugatti had clearly indicated that certain repairs must be carried out exclusively within their factory environment. Nevertheless, Mat and his small team proceeded with determination, carefully dismantling the vehicle one component at a time. As the work progressed, it became increasingly clear that the project was no longer simply about repairing a damaged car. Instead, it had evolved into a broader challenge to the idea that only manufacturers hold the authority to repair and control their own vehicles. As Mat continued deeper into the rebuild, he began to uncover unexpected details that raised further questions. One particular discovery led to speculation about what Bugatti may have already known regarding a critical internal component. This shifted the nature of the project from a standard restoration into something resembling an investigation. Viewers were no longer only watching a car being repaired. They were also witnessing a process that seemed to expose hidden aspects of one of the world's most exclusive automotive brands. One of the most technically demanding stages of the project involved a task many considered nearly impossible, which was separating the Bugatti Chiron into two distinct halves. According to Bugatti, this procedure is intended to be performed solely within their factory using specialized equipment operated by highly trained technicians. For an independent builder such as Mat Armstrong, attempting such a procedure was viewed as extremely risky, and many doubted whether it could be done correctly outside of Bugatti's controlled facilities. Despite these concerns, Mat and his team approached the challenge with confidence and careful planning. They systematically removed components, disconnected integrated systems, and followed a detailed step-by-step process to divide the vehicle without introducing further damage. Successfully completing this task represented a major milestone, not only for the project itself, but also for the wider automotive community. It demonstrated that independent builders are capable of performing complex operations that manufacturers claim can only be executed within their own environments. Once the vehicle had been separated, the direction of the project began to shift. The focus moved away from whether the task could be completed and toward how effectively the car could be restored. Numerous challenges still remained, including repairing damaged components, sourcing parts that Bugatti was unwilling to supply, and developing custom solutions where original components were unavailable. Among the parts requiring attention was the gearbox mounting bracket, a component responsible for connecting the engine to the transmission. At first glance, it appeared to be just another damaged piece. However, upon closer inspection, Mat noticed something unusual. The bracket was located deep within the rear section of the vehicle, far from the primary impact zone. This raised an important question. Why was this part damaged? And how did Bugatti's inspectors identify it during their initial assessment? This observation led to one of the most debated aspects of the entire rebuild. The gearbox mounting bracket is a relatively small but essential cast aluminum component that plays a crucial role in securing the engine and transmission together. What made the situation particularly intriguing was that the damage had been identified during an insurance inspection conducted with Bugatti's involvement. According to Mat Armstrong, this prompted a straightforward yet compelling question. How did they know to inspect that specific component in the first place? Considering that the car had suffered a front-end collision, it would have been logical to focus primarily on the front section rather than a hidden component located at the rear. This led to speculation that Bugatti may have already been aware of the component and its potential susceptibility under certain conditions. If this is accurate, it suggests that the damage was not entirely random, but rather something that could be anticipated in similar crash scenarios. While this interpretation might initially seem negative, it could also reflect intentional engineering design. In many cases, engineers design certain components to fail in a controlled manner during an impact in order to protect more critical and expensive systems. In this context, the gearbox bracket could function as a sacrificial element, absorbing energy and preventing damage to the transmission. However, this raises additional questions. If the failure of this component is expected and understood, and if it is replaceable, then why was the vehicle declared beyond repair? Why would Bugatti refuse to provide a replacement for a part that appears to be serviceable? These questions introduced a deeper layer of complexity to the narrative, transforming what began as a technical repair into a broader discussion about how manufacturers manage repairs and limit independent intervention. As more people reflected on these issues, the rebuild of a single vehicle began to symbolize a larger conversation about ownership, control, and transparency within the automotive industry. Rather than simply replacing the damaged gearbox bracket, Mat Armstrong and his team chose to enhance it. Since an original replacement part from Bugatti was not available to them, they turned to modern technology to design an improved version. The process began with 3D scanning the damaged bracket to create a highly detailed digital model. This model was then analyzed and refined using computer-aided design software. They observed that the original component had been manufactured using a casting process, which requires consistent thickness to ensure uniform cooling. Although effective, this method can limit optimization in terms of both strength and weight. In contrast, the replacement part would be produced using CNC machining, a process that allows material to be placed precisely where it is needed. This enables reinforcement in high-stress areas while reducing material in less critical regions, resulting in improved overall performance. By adopting this approach, the team successfully created a gearbox bracket that not only replaced the original, but also enhanced its design. This represented a significant milestone in the project, illustrating that independent builders are no longer restricted to replicating factory components. Instead, they are capable of analyzing, improving, and in some cases surpassing original engineering solutions. This challenges the assumption that manufacturers always produce the most optimized parts and highlights the growing role of advanced technology in modern automotive development. At the same time, this development raises important questions about why companies such as Bugatti limit access to their parts. If independent builders can create superior and more cost-effective alternatives, this could influence how high-end vehicles are repaired and maintained in the future. This aspect of the story extends beyond a single component and reflects broader themes surrounding the future of automotive repair and the relationship between manufacturers and vehicle owners. While attention surrounding the gearbox bracket continued to grow, another key aspect of the rebuild progressed more quietly: the exhaust system of the Bugatti Chiron. Although often overlooked, the exhaust system plays a crucial role in shaping the overall driving experience. The Chiron is powered by a rare and highly advanced W16 engine, yet many enthusiasts feel that its sound is quieter than expected. This is largely due to design decisions aimed at meeting global noise regulations and appealing to a wide audience of customers. As a result, the factory exhaust system prioritizes sound reduction while still maintaining performance. However, Mat Armstrong and the vehicle's owner desired a more aggressive and expressive tone. To achieve this, the entire rear exhaust assembly needed to be removed, a complex process involving the disassembly of multiple components and careful handling of a sophisticated titanium system. The exhaust system was then sent to Valvetronic Designs, a company specializing in custom exhaust solutions. Their goal was not simply to increase volume in an unrefined manner, but to enhance the natural characteristics of the engine while maintaining a level of refinement. This included retaining primary catalytic converters to ensure emissions compliance, while removing secondary restrictions that limit airflow and sound output. This approach clearly illustrates the difference between factory engineering and custom modification. Manufacturers must adhere to regulations and brand considerations, while independent builders have the flexibility to prioritize personal preferences and performance improvements. This portion of the rebuild highlights not only restoration, but also customization beyond what the original manufacturer provides. Other elements of the Bugatti Chiron, including the wheels and braking system, were also carefully examined and rebuilt. Given the vehicle's extreme performance capabilities, even minor inaccuracies can lead to significant issues, making precision absolutely essential. To achieve this level of accuracy, the team used advanced 3D scanning technology to capture precise measurements of the components. This enabled them to design custom wheels that fit perfectly around the large brake calipers, which are significantly larger than those found on standard vehicles. With only a few millimeters of clearance between the wheels and brakes, precision was critical. Digital tools eliminated guesswork and reduced the likelihood of costly mistakes, demonstrating how modern technology has transformed the process of automotive design and modification. Attention was also given to the cooling system, which had suffered substantial damage during the crash. The vehicle's multiple radiators, including the air conditioning condenser, required repair. Instead of sourcing new replacements from Bugatti, which would have been both expensive and difficult, the team opted to have them repaired by independent specialists. A technician named Bob assessed the damaged radiators and determined that the situation was manageable. Although one radiator had a hole and another was bent, these issues could be resolved with the proper tools and expertise. He explained that these components, while high performance, were not irreplaceable and could be restored or recreated. This further challenges the belief that only manufacturers can service such advanced vehicles. Another notable element of a rebuild is the unconventional logistics involved. Components are being transported between locations, including the United Kingdom and Miami, sometimes carried in suitcases. While unusual, this method allows parts to be moved quickly without relying on traditional supply chains. The project operates entirely outside of Bugatti's control, relying instead on independent networks and personal connections. Despite these logistical challenges, the rebuild has progressed into a fabrication stage where ideas are being converted into physical components. The gearbox bracket is being machined, the exhaust system constructed, radiators repaired, and custom wheels designed. Each step brings the vehicle closer to completion, demonstrating that the project is not merely theoretical, but actively advancing. In the final stages, the Bugatti Chiron begins to come together once again as a fully functional hypercar. The custom exhaust system developed by Valvetronic Designs is ready to produce a more aggressive and emotional sound from the W16 engine. The CNC machined gearbox bracket represents both innovation and improvement over the original design. The repaired radiators demonstrate that not all damaged components require expensive replacements. The custom wheels, designed with precision using 3D scanning, ensure that performance and aesthetics work together seamlessly. Together, these elements transform the vehicle from a damaged machine into a refined and enhanced version of its original form. At the center of this transformation is Mat Armstrong, whose work has captured the attention of millions. His project challenges the belief that only manufacturers can build and repair complex machines, instead showing that dedication, skill, and persistence can achieve remarkable results. As the vehicle approaches completion, the story reaches a meaningful conclusion. The once written-off Bugatti Chiron is no longer simply a symbol of loss. It now stands as evidence that limits can be questioned, systems can be challenged, and innovation can arise from unexpected sources. Even if some questions regarding Bugatti's decisions remain unresolved, the rebuild itself has already made a lasting impact on how people view vehicles, ownership, and repair. Even after the major components have been restored, replaced, or upgraded, The final phase of reassembly, testing, and fine-tuning remains essential. Every system must operate in harmony, including the engine, transmission, cooling system, electronics, and suspension. Careful inspections and repeated testing are necessary to ensure that no issues remain before the vehicle is considered complete. This stage also highlights the contrast between factory, assembly, and independent rebuilding. While factories operate under controlled conditions with specialized equipment, this rebuild relies on flexibility and problem-solving. Despite these differences, the objective remains the same: achieving or exceeding original performance standards. As completion nears, anticipation builds toward the moment the car will be started and driven again, marking both a technical and emotional milestone. Ultimately, the rebuild of the Bugatti Chiron is more than a mechanical restoration. It is a narrative about challenging limitations, exploring possibilities, and redefining what can be achieved in modern engineering. Through this project, viewers gain insight into the complexity of high-performance vehicles, the level of control manufacturers maintain, and the capabilities of independent builders who find creative ways to overcome obstacles. The questions raised throughout the project, particularly regarding the gearbox bracket and Bugatti's awareness of it, may never receive definitive answers. However, the rebuild itself provides a compelling response by proving that the vehicle was indeed recoverable. This project demonstrates that what may appear impossible is often simply a challenge awaiting a solution. As the story continues to circulate, it has grown into a broader discussion about control within the automotive industry. It reveals how manufacturers influence repair processes and parts availability, while also showing that independent builders can operate beyond those constraints. Mat Armstrong has, in many ways, become a symbol of this shift, not by intention, but through the significance of his work. The Bugatti Chiron rebuild has become part of a larger movement that promotes curiosity, innovation, and independent thinking. It shows that modern vehicles, regardless of their complexity, are not entirely inaccessible. This understanding encourages individuals to explore, learn, and engage more deeply with automotive technology. Even after the project concludes, its influence will continue to expand. It has already reshaped perspectives, sparked discussions, and inspired new approaches to vehicle repair and construction. In doing so, it stands not only as a successful rebuild, but also as a meaningful contribution to the evolving relationship between people, technology, and the machines they own.